let's look at another useful protocol, TFTPD. We'll label this section after its expanded name, Trivial File Transfer Protocol Daemon, or TFTPD. This protocol is commonly used to move files to and from systems, such as network configuration files for firewalls and routers and switches. It features fast connectionless, which means it's UDP-based, file transfers, and is again often used to move files to and fro networked systems. So for example, VoIP phones, Pixie configurations, router, firewall, switch configurations, and so on. Again, it's connectionless, so you won't see any traces when using netstat in the connection table when two parties are connecting or communicating using TFTPD. But nonetheless, it's fast and usually works pretty well in a local area network environment. Try not to use these sorts of protocols across the WAN, again, because if you lose packets, then you'll have broken configurations or broken files, and you'll have to use some other means of confirming the transfer, such as using MD5sum or any other checksum-based utility. So with that said, how do we get it set up on the system? We can use our remote system serve4 as an example, since it's running the later version of the OS, and query to see whether or not it's even installed using rpm query all grep case insensitive for TFTP. And also, TFTP is implemented as two components, a client and a server. Neither are installed on the remote system. Let's just note that it's implemented as two components. Client, which is the TFTP star package, and server, which is TFTP server star package. We can confirm by examining the contents of our repository from the browser, and here's the NTP site from our previous study. So this is the page where we would search for public NTP servers using any of the links that you see here for the various strata level that we're interested in. But while that search is in a separate shell, we'll connect to the location of the RPMs on the Apache web server, Linux CBT Media 1. This will bring down the RPMs, and when complete, we will Control F to search towards the bottom of the page for TFTP. And there we see the client package as well as the server package. So if you need client support allows you to move documents from the local system to a remote TFTP server. It is indeed the TFTP client, analogous to the FTP client in the FTP client server set. So you'd install this program if you need it. And we'll go ahead and install it anyway because it might be necessary or might prove useful. So RPM, in fact we could use yum, install, prompting with a yes, TFTP. And this will search the repository for TFTP, and then we see it's installed TFTP. So now when we rerun rpm query all grepping for TFTP, we'll see momentarily that indeed the client package is installed. Let's enumerate the contents of the package. You see that it includes beneath user bin the client and a man page. Man of TFTP returns usage information, which is typically TFTP optional options followed by the target and a command, which in and of itself is optional, that you'd like to have the TFTP run, equivalent to using TFTP in interactive mode. Again, it can be used to transfer files like FTP in either ASCII or binary modes, and you can connect to a host using a given port other than the standard TFTP port. And the commands would include gets and puts, for example. Get a given file or get multiple files. Put a file or put multiple files. So the usage is really simple, and we have the package installed, but we're more interested right now in the server, which we'll install by using yum and the name of the package, which is TFTP-server. Let's go ahead and just one note, before we executed yum install TFTP, the reason why the server wasn't installed is because the unique characters in the server include TFTP, but also include the dash in server. So we have to indicate the full TFTP-server name in order for yum or RPM to recognize and perform the appropriate match. So let's now indicate TFTP server. This will install the server package and will enumerate its contents momentarily. Also notice that as a result of installing TFTP server, the dependency for ZynetD was met. ZynetD is a super server. Let's just note, so tasks include 1, install TFTP client, which we did using yum-y install TFTP, and install TFTP server, which we did using yum-y install TFTP-server. Note, this also installs ZynetD dependency, and that is because TFTP server is controlled by ZynetD, the super server, which means in order to start your TFTP server, you need to enable it via ZynetD. So our next task is to configure and start TFTP via ZynetD, the super server. The configuration files are located beneath etc zynetd.d, and we'll find one for TFTP. So modify this file prior to starting TFTP. Let's return to the shell. Navigate to etc zynetd.d, that is, and you'll see there's an entry for TFTP. If we cap the contents of this entry, you'll see that it includes basic directives, and if we modify it, because we need to change disable from yes to no, let's modify TFTP, and we can change disable from yes to no, or what I like to do is keep 2 lines, disable equals yes, and comment it out, disable equals no, uncommented, and then start the service. So here are some directives that are passed into TFTP server. The socket type ZynetD needs to know. It needs to know how to start the program, and it is a datagram-based service. It's UDP. It has to wait. It cannot spawn multiple instances. It's a sequential connectionless protocol. It will run as root. The binary which will be executed is located beneath user sbin, and it's known as in.tftpd, as are many of the old-fashioned binaries within Linux and Unix are known as, such as telnetd and others. Arguments. By default, TFTPD will expect to serve files from /TFTP boot, so ensure that this directory exists. But if you want to serve files from a different directory, then ensure that the other directory exists and indicate it in this configuration file. The protocol will not be disabled, but it is by default. Per source connections, maximum 11, connection per second 102, flags IPv4. Let's save the changes. Now again, ensure that the directory exists at the root of the file system, and it does. You also need to ensure that there's content in the TFTP boot directory for the sake of being able to write a file. So for example, let's say we wanted to save our firewall configuration to the TFTP boot directory. we should go ahead and create that file. Let's navigate to TFTP boot, and we'll touch, this will be for our router, so we'll call it Linux CBT router1.config. So this will be our file, router1.config, that we will attempt to write from the router. Again, the router is going to use the TFTP protocol to save its configuration to this file once we've connected to the router. Then we could also use the TFTP client to download the file, let's say from a different host. Let's find a free window here, and from this window we will log in to the router, the default gateway that is. Now we're on the router, so we want to copy the configuration using copy running configuration to TFTP, and we'll list this as another task. Copy Cisco router configuration to TFTP server. To do so, we'll execute copy TFTP, or copy running that is, config to TFTP, the IP address of the TFTP server, which in our case is 75. We'll confirm the IP address from the command line, 199. So 75.199. But we have to be sure that TFTPD is running. So from the local, or from the remote system that's running the server, we'll execute netstat mul. Here's a usage of netstat to see the UDP listeners. If we turn on P, we'll see what's running. And notice we don't see the TFTPD port. TFTPD runs by default on 69, and we don't see it listening. That tells us that ZynetD is not running. We can do a service ZynetD status to see whether or not it's running, and it isn't. So we need to start ZynetD as part of our configuration and start of TFTPD. So we modify it, and then we execute service ZynetD start to start ZynetD, which will handle all inbound TFTPD services. So now we've started it, and let's go ahead and re-execute netstat mul with the P option to see whether or not TFTPD is running. We'll scroll up. Now notice that we see protocol is bounded with ZynetD to the port 69. This is the default port. We should just note that. Perhaps we'll list it here. Note, TFTPD listens to UDP 69 by default.